So last section we're going to look at in chapter 1 is 1.6. And 1.6 is on basically creating a new function from ones that you are given. Okay. So I'm going to show you how we can do that. So I'll give you two functions, and I'm going to have you combine them together to form a new one. And we're going to do it in different ways. One way that we can do it, most basic way, is to just do simple addition, subtraction, multiplication, or division. So here's kind of a real quick example. Say I had function f of x and it was 3x. I have another function g of x and that's called 4x. And I said for you to combine those together to create a new one by adding them. So in other words, I want you to find this. What would f of x plus g of x be based on those two formulas? 7x. Yeah. So 7x is a new function that I created by combining the two that I had together. Specifically, that was with addition. Now, sometimes when you combine them together, they don't simplify because they're not like terms. 3x and 4x are like terms. So that's why I was able to add them and get 7x. But let's say I had 3x squared and 4x. And I said to combine those by adding them. Well, there's nothing you can do. When you add them together now, you just have 3x squared plus 4x. That's the final answer. Okay. So that's a different problem than the first one, where you cannot combine anything because they're not like terms. Okay. But that's what we're going to try to do. Okay. So let's use these two functions, x squared and the square root of x plus 1. Okay. First of all, those are not like terms. Like terms would be like if you had x squared here and like 2x squared here, or you had something with an x squared. Okay, you've got a square root. So I want to take those two functions and I want to combine them together by adding them. Since they are not like terms, can I combine them together when I add them? What do you think? Yeah, hold on, let me get a here. Juliana, what do you think?
No.
No. So when I want to create a new function by adding these two together, I would literally just write down the first one plus the second one. There is no way to combine those together. All right. Let's create another new function by taking those two and dividing them. Anyone think they could tell me when we divide them, what would be on the top and what would be on the bottom? Well, Josh, could you tell me what would be on the top?
X squared.
Yep, x squared on the top. And what about on the bottom?
The square root of x plus 1.
Yep, square root of x plus 1. So that's how you combine them. Now, what did we leave in the bottom that normally in math we don't leave in the bottom? Something there we normally don't leave there. Yep. Right, square root. So remember, to fix having a square root in the bottom, this isn't what we're learning today, but it's something you kind of have to know from algebra. You multiply the top and the bottom by the square root you're trying to get rid of. And what that does is it gives you something that's equal to what you had before, but it no longer has a square root in the bottom. Okay, so we multiply straight across. X squared times the square root of x plus 1. There's not much you can do with that. But the bottom is the square root of x plus 1 times the square root of x plus 1. So you're multiplying it by itself. What would you get when you multiply together the two things in the bottom? So think of it, since it's the square root of x plus 1 times itself, think of it this way. It's the square root of x plus 1 to the second power. What would happen here when you do that out? Yeah?
Just cancels.
What would cancel?
The square root and the square.
The square root and the square, and what would you be left with?
Just x plus 1.
Just x plus 1. Yep. So when you combine two functions by dividing them, if the bottom one had a square root in it, a lot of times we got to fix that so it doesn't end up in the bottom. Okay? And that's how you fix it. Okay, so what's the domain and what's the range going to be? Well, let's go back and look at these two. Let's think of this one as, we'll just call it the red one, and this one, oh, actually, that'll be the black one. The one on the right will be the red one. Let's say that this black circle represents all the numbers that you are allowed to plug into f of x, which in this case would be any number that you want, because you're never going to be taking a square root in the black one, and you're never going to be dividing by 0. Now, let's say this red circle represents all the numbers that you are allowed to plug in for x right there. When you combine these two functions together to create a new one, the domain is like that. The domain is the overlap. It's all the numbers that are in the black circle and the red circle. So that's how you can think of the domain. It's the overlap. And I write that down right here. The domain of the new function that you create is all x values that belong to both of the original functions. Okay, so the domain is the numbers that belong to both original functions, and if you combine two fractions together, if you combine something together with division, if you introduced dividing by 0, we have to also watch out for that, because you're not allowed to divide by 0. Like if I had these two functions, like f of x equals 3x, g of x equals 2x, by themselves, I can plug in any number that I want. But if I combine them with division, look what happens. Do I have a fraction now that has a letter in the bottom? Yes. If you end up with a fraction that has a letter in the bottom, you cannot end up with a 0. So the domain here would not include the number 0, because if it did, you'd be dividing by 0. That's no good. All right, so we'll practice a few more of those and just kind of get a feel for how to find domain. Okay, so while we talked about that, can't divide by 0, what's the other thing that we have to watch out for? We're not allowed to do something else. Can't divide by 0. And we also can't, yeah?
Negative numbers.
What with negative numbers?
The square root unit.
Right.
The square root.
We don't ever want to take the square root of a negative number. So those are two important things that we have to look out for in every problem. All right, let's try this one. It says to perform the operation that I'm going to give you below, and then find the domain. Okay, the first step to figuring out the domain when you combine these together is first figure out the domain when they're separate. Okay, do that first. Okay, let's look at f of x. Austin, in f of x, do I have any fractions in that one with a letter in the bottom of a fraction?
I'm sorry, could you repeat that?
So looking at f of x, do we have any fractions that have letters in the bottom?
No.
No, there's no fractions in f of x at all. So we don't have to worry about dividing by 0 with what they gave me for f of x. Calvin, do we have any square roots in f of x?
We do have a square root.
Yes, we do have a square root, and we have to be careful that we don't try to take the square root of what kind of number?
Negative.
Negative. Okay. So now, does anybody think they could tell me what I could plug in for x so that I guarantee what's underneath the square root is not a negative number? It can be 0, or it can be higher, but it cannot be negative. Yeah?
-3.
Negative 3.
Oh,
Like that's the only number I could plug in?
-3 and higher.
Negative 3 and higher, yes. Can you include the negative 3? Yes, because if you plug in negative 3, you'd have 0 underneath the square root. And the square root of 0 is fine. People mix up square root of 0 with dividing by 0. They're different. Square root of 0, no problem. So the domain is all numbers from negative 3, and you said and up. So what would be the highest number you could pick? Infinity. And can you include infinity? No, because you can't reach it. Okay, so that's your domain, negative 3 and up for f of x. All right, now let's look at g of x. Square root of x minus 2. Do we have any fractions in g of x that have letters in the bottom? What do you think, Ariel? No, then we don't have to worry about dividing by 0. Do we have any square roots in g of x? Oh, Martine?
Wait, what? What was the question?
Do we have any square roots in g of x?
Yes, we do.
Yeah. So what do we want to make sure that we don't do?
No, we don't have any negative numbers.
Right. We don't want to take any square root of a negative number. Okay, so same question I asked before. What would x have to be to guarantee that what's under the square root is not negative? It can be 0 or higher, but it can't be a negative. Yep.
Positive 2 or higher.
Positive 2 or higher. Positive 2 including it or higher. All right. Any question how we got the domain of each one of them individually? Okay, now we're going to combine them. I want to combine them by adding. Okay, so first of all, they are not like terms. For square roots to be like terms, you have to have the same thing under the square root. Like if you had the square root of x plus the square root of x, you could say that that's 2 square roots of x. But this is an x plus 3, that's an x minus 2. So they can't be combined together. So what would I write down when I add f of x and g of x if they're not like terms? Yeah?
The square root of x plus 3 plus the square root of x minus 2.
Yep, that's all you can do. Now I want to know the domain. So the domain is the overlap from the 2 original ones. Okay. If you're not sure where the overlap is, think of these as pictures. All right. The first domain, let's put -3, -2, -1, 0. The first one had a domain from -3 and up. So that would be from here, going that way forever. The second one had a domain of 2 and up. So when we combine them, the domain is the overlap between the blue and the black arrows. Anybody think they see where the overlap is? Yeah.
Is it at 2
2
or higher?
or higher. Yep, 2 or higher. That's the overlap. So the domain here is any number 2 and up. Now, if you look at it, you might say, well, yeah, but you could plug 0 in here. Right? You could plug in 0 and you get 0 plus 3 is 3, and that's a positive number. But what happens if you try to plug 0 in right here? What do you get?
-2.
Yeah, you get a -2. So you have to be able to find a number that works here and here. That's why it's the overlap. Any questions on that one? Let's try a little bit different. Okay, same functions again, f of x and g of x. This time I want to divide them. Now, I know when I divide them, I am going to end up with a square root in the bottom. For now, I'm not worried about fixing it. Well, we can just leave it. So, Ben, when I combine these by dividing, what would I get? Ben.
Repeat the question?
What would I get when I divide those two functions?
X plus 3 over x minus 2.
We lost something. Yep.
Square root of x plus 3 over square root of x minus 2.
Square root of x plus 3 over square root of x minus 2. Now again, we're not supposed to leave the square root in the bottom, but I'm not worried about that this time. Okay. What do you think the domain would be here? Still has to be the overlap, but we have to be a little bit careful. Anyone think they see there's going to be a very small difference between this domain and the one that we had up above? Yeah.
Positive 3 or greater?
Well, you could still plug in a number like 2.5 and that would work. Because if you plug 2.5 in the top, you get a positive. If you plug 2.5 in the bottom, you get a positive. So you can still go lower than 3. You can't go too low, but you definitely can go lower than 3. Yeah?
Would you not be able to go lower than 2? Like, would you not be able to go at 2?
Right, you wouldn't be able to go at 2 this time. So the domain would be that compared to what we had before. Why can't we include 2? 2 is in the overlap between both of them. But what happens if we include 2? Yeah.
We would be divided by 0.
Yeah, then we'd be dividing by 0. So that's a problem as well. So for this one, the domain is 2 and up, not including the number 2. Okay, a little tricky, but big, important difference between those two domains. Questions on that? All right, and we could add these, we could subtract them, multiply them, divide them. You can combine these all different ways. All right, but let's try a different one. Okay, here's f of x divided by g of x. And the two functions I'm giving you are below. Alex, what's f of x in this one?
Absolute value of x.
Yep, perfect. Absolute value of x divided by, Sadie, what's g of x?
X.
Just x. Okay, so we're going to graph that, and we're going to find the domain and the range. Have we talked about how to put the absolute value in on the graphing calculator? We done that? Okay. So I'm going to go y equals. Can someone remind me then what do you press to do absolute value? Yeah?
If I'm not incorrect, it's second? Or do we just press math?
We just press math.
We press math, we go over to numbers.
Yep.
And then the first one.
And then the first one, perfect. So absolute value of x. Oops. And then type in divided by x. That's how you type it in. All right, let's do zoom 6. And we're trying to find the domain and the range. Well, domain you can get without even using the picture. Okay. Are there any square roots in my final answer? What do you think? Gracie, are there any square roots in my final answer? No, so I don't have to worry about taking the square root of a negative. Are there any fractions with variables in the bottom? Yes. Then I do need to worry about dividing by 0. What number would I not be allowed to fill in right there? Because if I did, I'd be dividing by 0. Yeah?
0.
0. So the domain is all numbers except 0. Okay. So again, 2 ways to write it. You can tell me what the domain isn't. But most of the time, they're going to ask you to say what the domain is. Okay. When there's one number you can't include, you have to break it into 2 pieces. Okay. Here's 0. Can we include 0? No. Could we pick anything lower than 0? All right, so let's start with that. How low could we pick? Negative infinity. And we can go right up to, but not including what number? 0. Or, did I mention that symbol yesterday? So,
It's unity, right?
yeah, means union.
Yeah.
Yeah.
I think you mentioned it last academic week.
Last academic week. Okay. So that symbol in math, it just means or. So you can either pick a number lower than 0 or higher than 0. Just not 0. If you could pick a number higher than 0, how low of a number could you pick, not including this number?
0.
Yes. That means you could pick like 0.000000001. Okay. How high of a number could you pick? Infinity. And that's how you can describe the domain. Which way you'd have to describe it? Well, it just depends on which tools are available when you click in the box. If I give you this union symbol in the box, then I'm probably going to want you to describe it with that, and I wouldn't give you this inequality symbol. If I gave you both, well, then I'm telling you you could describe it either way. But if you click in the box and the symbol's not there, chances are it's because you don't need the symbol. Okay, so that's the domain and the range. Does it look like that graph goes up and down forever?
Yeah. So the slides?
Well, it goes left and right forever, so that covers the domain.
Oh,
So we got that.
no.
But how about up and down?
No.
No, it's very limited in the range. It looks like there's only 2 values that it hits in the range. What does it look like those 2 numbers are? Yeah.
-1 and 1.
Right, because no matter what you plug in for x, like try plugging in 5 here. What's the absolute value of 5 divided by 5?
1.
1. Any positive number that you plug in for x always comes out to 1. Try 7. Absolute value of 7 is 7. Divided by 7 is 1. Now try a negative number. Try -2. What's the absolute value of -2?
2.
2. And what's 2 divided by -2?
-1.
-1. So that's why this formula will only give you one of 2 answers, no matter what you type in. The number 1 or the number -1. So when those are the 2 numbers in the range, we just write them. That is not an interval. Okay? I'm not saying that the range is every single number between -1 and 1. I'm saying the range is exactly -1, +1. That's it. You know it's not an interval because I didn't use brackets or parentheses. Yeah, any question on that? All right. So that's combining functions with adding, subtracting, multiplying, dividing. Now I want to look at how we can combine functions using what's called composition. So first, let me show you the notation when you're asked to do a composition, what it looks like. It's going to look something like this. And the way you pronounce it is G, and each left parenthesis is the word of. G of f of x. Now, if I said to you, find G of 9. What does that mean to do with the number 9 and the function that's labeled G?
Can you repeat that?
So if I said find G of 9, like we talked about how to evaluate, I think we did that yesterday. G of 9. What does that mean you do with the number 9?
You insert it.
Insert it where?
For the x.
For the x, in which formula?
Gx equals the square root of x.
Yeah, function G. So you take 9, you fill it in for the letter in function G, and then tell me what you get. So in this case, you'd plug in 9, and you'd have square root of 9, which is?
It's 9. Oh, sorry. Square root.
Yeah,
3.
3. Well, what we're going to be plugging in for the letter now is not going to be a number. You're still going to plug in something right here for that letter. But what you're going to plug in for that letter is this entire formula. That's composition. You're taking the formula from one function and you're plugging it into the letter in the other one. That's composition. So let's do it. So we're going to find G of f of x. First thing I like to do, just to kind of make it a little bit simpler, is look up what the inner function is. Okay? So the inner function is the one that's on the inside. G is the outer function, because that letter is on the outside. What does it tell me up above that f of x is? What's my formula for f of x?
X squared plus 3.
X squared plus 3. So I just changed f of x to what it tells me f of x equals. It's x squared plus 3. Now, in function G, everywhere you see a letter, you're going to replace the letter with what's inside those parentheses. X squared plus 3. All right, so let's do it. So take function G and replace the letter with what's inside the parentheses. What we just created in that box is a composition of function f and g. That's how you do it. All right, let's try it the other way. This is g of f. The bottom one is f of g. No, they're not the same. They're different. So start with this inside function. Okay. Look up above. What does it tell me up above that g of x is equal to? What's my formula for g of x? Yeah.
Square
Square root of x. So I'm just replacing the name of the function, g of x, with what it actually is from up above. Replace the name with what they tell me that it is. Okay. So now, in function f, all the letters are going to get replaced with what? Square root of x. You're going to take square root of x and fill that in for all the letters in f. Okay, so there's f off to the side. Change all the x's to square root of x's. So square root of x squared plus 3. Now, when we did that up above, nothing simplified. You can't simplify what's in this box at all. But this one does simplify. What's the square root of x squared? Yeah,
X.
it's just x. So in this case, that is the final answer. And again, the point I'm trying to show you here, g of f and f of g, they're different. Any questions on that one? Okay, we haven't found domain and range yet. We are going to do that. All right. But for now, I just want you to understand how to take two functions and compose them. This is another notation. I don't use this notation. I'm just going to let you know, if you see that in the book, that thing that I circled means what's off to the right. On the test, I won't use this notation either. I'll always use the one that's on the right. Because the goal is not to have you get confused by different kinds of notation. I picked the one that's on the right because I think it's simpler. To me, it just makes more sense. All right, so any questions before we start looking at how to find the domain? Okay. So when you're finding the domain, remember there are two functions here. I call the one that's on the inside the inner function. So in this case, it would be f. And I call the one on the outside the outer function. And in that case, it would be g. So when we're finding the domain, the first thing we have to do is focus on the inner function, inside function. And what we're going to do is we're going to look at that function, and we're going to ask ourselves two questions. What are the two things that we have to watch out for when we're finding the domain? We do not want to do what? What's one thing? Yep.
If we're dividing, you don't want to divide by 0.
Right, we do not want to divide by 0. So in the inside function, if there is any number that would cause you to divide by 0, you need to tell me, don't use that number. That's one thing. What's the other thing that we want to make sure we don't do? Yep. Right, we don't want to take the square root of a negative number. So looking at the inside function, if there is any number that you would plug in that would cause me to take the square root of a negative, you need to tell me, don't use that number. Right? So we need to eliminate those two issues in the inside function. That's step one. And then step two is now we're going to look at the final answer. And we're going to do the same thing again. When you put these two functions together, are there any additional values that you didn't already eliminate in step one, but now they need to be eliminated in step two because of the way the functions came together? Did you somehow create a new fraction where you could divide by 0 that you didn't have before? If so, we have to eliminate dividing by 0. Or when you compose the functions, did you somehow introduce a square root? where now you could be taking the square root of a negative, and before you weren't. Okay. So look at the inside function, eliminate dividing by 0 and square roots of negatives. Then look at the outside function, or look at the final answer. And then eliminate dividing by 0 and square roots of negatives. All right, that's pretty much it for finding the domain of a composed function. So we'll practice composing a couple more functions first, and then after we do a couple, we'll try finding domain. Okay. So let's try finding f of g of x. Start with the inside function and replace the name with the actual formula. So what is g of x in this particular problem? Yeah.
Square root of x.
Square root of x. So replace the name with what it tells you it equals. And now, in function f, what are we going to change all the variables to?
The square root of x.
Yes. And if you do that, Ariel, can you tell me what you would get?
It's just the square root of x plus 1.
Like that?
Yeah.
Yes. That's f of g of x. Not finding the domain right now, just composing them together. All right, let's try it the other way. G of f of x. Okay. Somebody walk me through the first thing I should do. Yep.
First, you need to put the g and then in parentheses put the x plus 1 in there for f of x.
Right. Replace the name with what that name actually is. It's f of x, but what is f of x? X plus 1. So that's step 1. Okay. Now, can somebody else tell me the last step? In this function, do this. That's basically what you need to tell me. Yep.
Do the square root of x and plug in x plus 1 for x.
So plug in x plus 1 for x in function g. Yep. So if you look at function g, and everywhere that you see a variable, change it to x plus 1. Okay, f of g and g of f look similar, but notice they're not exactly the same. One of them has a plus 1 on the inside, one has a plus 1 on the outside. So they are a little different. All right, so any questions on that composition? All right, now let's try finding a domain. Okay, I do a lot with the square roots because square roots is something that can be tricky, and you have to know what you're doing when you find the domain. All right, so this one says to find, I would just write the bottom notation, g of f and f of g. Okay, let's start with g of f. Take the inside function and replace it with the formula, x squared minus 1. Now, Tom, in the function that's g, what are we going to replace all the variables with?
square root of x. Or no?
Well, that's the g of x, but we're plugging something in for the x right here. What are we filling in for that?
X squared minus 1.
All right.
Already did that.
So what would you have when you write that whole thing down?
Square root of x squared minus 1.
Exactly, the square root of x squared minus 1.
I already did that.
You already did that?
It looks like you already did that with the g of x squared minus 1.
Well, here I still have the g, but I haven't written the square root symbol yet. Yeah, so you got to make sure you write down the square root symbol and then x squared minus 1. And that's it. That's your final answer. Now, I want to know the domain. Start with the inside function. Inside function is f of x. Look at f of x. Okay, ask yourself two questions. Are there any square roots in f of x? No. Are there any fractions in f of x that have letters in the bottom? No. So right now, from step 1, the domain is all real numbers. We haven't eliminated any values yet. Now let's look at step 2. Examine the final answer. Okay. Looking at the final answer, are there any fractions with letters in the bottom? No. Are there any square roots? Yes. We don't want to be taking the square root of a negative. So we need to make sure that what I just circled always comes out 0 or higher. Another way to think about that is you need to think of what numbers can you square and then add 1 to each side. What kind of numbers can you square and they will come out 1 or higher? Think of numbers you can square that come out 1 or higher. Yeah?
Anything -1 or below and anything 1 or higher.
Yeah. If you square anything -1 or lower, like -2, if you square -2, you get 4. That's bigger than 1. So anything -1 or lower, how low can you go?
Negative infinity.
Negative infinity. So anything -1 or down, and then anything from 1 and up. So in other words, just don't pick a number between -1 and 1. Like don't pick 0.5. If you plug in 0.5 here, you're going to have the square root of a negative. Okay, and that's it. That's my domain. A little tricky because you got that x squared there. That's why it broke into 2 pieces. Okay, let's try it the other way. F of g of x. Okay, Olivia, what is g of x?
The square root of x.
Yep. So it says it right at the top. G of x is the square root of x. And now say the in formula f, what am I plugging in for the letter?
X squared minus 1. Wait, what did you say?
So in formula f, what am I going to replace the variable with?
My brain's like pausing.
What's that?
My brain's freezing.
That's okay. Yeah.
X squared minus 1. Oh, the square root of x.
This is what you're plugging in to formula f.
Oh,
Okay, so you're plugging in the square root of x everywhere you see a letter in formula f. So that's what we're going to do. Replace what I just circled in blue with the square root of x. So you've got the square root of x squared, and then you have a minus 1. What happens when you square and square root? They cancel out. And what am I left with?
X minus 1.
X minus 1. Now, if you just looked at the x minus 1, you might say the domain is all real numbers, because there's no square roots and there's no fractions there. That's just the final composed answer. You need to go back and start with the inside function. Okay? Look at the inside function right here. Does that have a fraction with a letter in the bottom? Martine?
No.
No. So you're not going to divide by 0. But does this have a square root in it? Yes. So what values would we be allowed to use for x in the inside function? Anything that's
Greater than or lower than 0. Wait, can you repeat what you just said?
Can you repeat what you said?
Greater than or lower than 0?
How can I be greater and lower than 0?
Wait, can you
That's
repeat?
like the answer to you have homework tonight is yes, no.
Oh. Can you repeat what?
So I want to know what numbers I could fill in for x so that this always comes out to what we need it to come out to.
Put as just what?
Yeah?
Anything 0 or higher.
Anything 0 or higher. So I think you meant greater than or equal to 0.
Oh, okay.
Not greater than or less than 0. Yeah, but yeah, greater than or equal to 0. Okay. So from the inside function, keep that in mind. We're already limited to 0 and up. Are there any square roots in the final answer? No. Are there any fractions with letters in the bottom in the final answer? No. Then the final answer doesn't add anything new we need to think about. The only restriction came from the inside function, which was 0 and higher. So the domain, 0 and higher. Okay, so any question on how I looked at the inside domain and got that, or why the final answer didn't add anything new I had to worry about? So we're going to try another one where we do domain. We're going to add range into it. Range isn't that much harder, because all we do with range is graph it on the calculator and use that to give us the answer. So step 1, you still need to figure out the domain, because that's going to tell you your window on this calculator. If you don't know where to set your window, the calculator is not really going to help you. So find the domain first, and then next, we'll graph on the calculator. And we're going to look for how high and low it goes. All right. I'm not going to do both. Let's just do the second one. There's no reason why. I just don't want to do both. So we're going to find f of g of x. All right, so f of g of x. All right, Ben, which function do I start with? Inner or outer?
You start with that.
Inner. Yep, so always remember, you always start step 1, we're looking at the inside function. Okay, so we're always going to start with the inside function. Okay, what's the, Austin, what's the inside function?
G of x?
Yep, and what does it tell me g of x is?
X minus 3.
Yes. So we're going to replace the inside function, g of x, that's its name, with what it actually is, x minus 3. Okay. Now, Braden, what formula, you don't have to tell me anything else, just tell me what formula am I going to plug into now?
You're plugging the x minus 3 into where the x is in the f of x.
Yeah, so we're plugging into f. Okay. What are we going to plug into f? X minus 3. Okay. So that was going to be a separate question, but you answered everything, so that's good. So we're going to plug in to function f, and we're going to fill in x minus 3. So here's function f. There's the x. Change that to x minus 3. Okay, so let's start with our domain. Inside function. Okay. G of x. Josh, does g of x have any square roots in there?
No.
No. Does it have any fractions with letters in the bottom?
No.
No. So then there are no restrictions on the inside function. But that's not the whole thing. Now we have to look at the final answer. Okay, looking at the final answer. How about Anthony, does the final answer have any fractions with letters in the bottom?
No.
No. Does it have any square roots in it?
Yes.
Yes, then we need to be careful. So there is something we need to think about. What kind of numbers could I fill in for x that would guarantee what I just circled is either 0 or higher? Yeah,
3 or higher.
3 or higher. Yeah. Okay, so that's the domain. And now range. Well, step 1 was to find the domain. We already did it. Step 2 is to graph that. And we're going to look at it on the calculator screen and see how high and low it goes. So square root of x minus 3. Zoom 6. Let's try that. Okay, so there's my square root. Remember, the square root is just a parabola that's on its side, half a parabola. And how low does it look like that blue curve goes? And then it stops and it doesn't go any lower. Yep.
0.
0. And it will hit 0 if you plug in the number 3. What's 3 minus 3?
0.
0. So when you get to 3, the y value is 0. So that hits 0 right there. What's the highest that this blue curve is going to go? Yeah? Infinity. It's just going to kind of keep going like this. Right? It's half of a parabola. It's just going to keep curving up forever. That's how you find the range. Okay. Any question on that? So it takes a little practice to get good at domain and range. It's not something that's easy right away. Let me see what I have left. Okay. So we did that yesterday. All right. So what I want to finish up with is talking about transformations. Okay, we already talked about all these transformations yesterday when we did quadratics. So when we did quadratics, we might have done something like this yesterday. What did the plus 3 added onto the end do to your function? Anyone remember? Yeah?
It raised it up on the y-axis, like the vertex.
Yeah, it shifted it up. Can you be more specific?
It shifted on the y-axis up 3.
Up 3. Yep, shifted it up 3. Well, it turns out if you did that, or you did that, or you did even like a trig function, Those are all shifted up 3. We don't know what some of these are. We don't know what a sine function looks like yet, at least I didn't teach you. But whenever you put a +3 on the end of any function, it would shift it up 3. So in general, if you had something like this, any function, that's what that represents. Any function with a +3 would shift it up 3. So what I'm going to do now is just kind of show you a formula and then ask you if you could tell me what it would do. Right? So here's the first one. Multiplying by a number in the front of the function. So yesterday that would have been like if I had x squared and I made it 3x squared. What does multiplying by a number in the front do? Yeah?
Vertical stretch and shrink.
Yep. Exactly. It's a vertical stretch or shrink. It doesn't matter what function you put here. X squared could be any function. But multiplying by a number in front will cause a stretch or a shrink. When would it stretch? What kind of number would A have to be?
Positive.
Nope, there's positive numbers that would shrink it. It has to be positive to not reflect it. But what kind of number would A have to be to stretch? Yep.
Greater than 1.
Greater than 1. And to shrink or compress, it would be a decimal between 0 and 1. Let's kind of just did this one. What happens when you add a number on the end of a function? What would adding a number on the end do? Yeah?
Move it either up or down depending on if it's a positive or negative.
Okay, well, I'm saying specifically add.
Okay, it would move it up.
Yeah.
The number.
Adding a number on the end would move it up. How about subtracting a number on the end?
It would move it down.
Would move it down. So up, down, in that order. Up, down. Okay. How about adding, but this time inside the parentheses? What would that do to a function? If you add a number inside the parentheses. Yep.
Left.
Yep, would move it left. What if you subtract a number inside the parentheses? Yep,
Moves to the right.
move it to the right. All right. Now, the negatives cause reflections. Does anybody remember when you put the negative in the front, what kind of reflection that is? A negative out in the front. This is the one that we could see when we did it on the parabola. There was one we couldn't see because it looked the same. This is the one you can see. So it reflects it over the
X-axis.
x-axis. And then when you put the negative on the inside, that reflects it over the
Y-axis.
the y-axis. Okay. So now using this chart, we're going to finish up with the last example. I'm going to ask you to draw something. But I'm not going to give you a formula. I'm just going to give you a picture. And I'm going to tell you to do something to the picture. And it's going to have some of these transformations in it. So there's your picture. Make that a little bigger so you can see it. Okay. Does everybody have this table first? Which one do you need to copy?
Go back. The last 4.
Last board? Okay, I'll put it back up
I think.
in a little bit. Okay, so I want you to do that to this picture. So there's no formula for the picture. You have to know what each one of those numbers would do to that picture and then do it. And the easiest way to do it is there's really 3 points that are important. This one, and that one. All you have to do is figure out what happens to those 3 points each time and then just connect them and you'll have your picture. Okay. What number do we focus on first? The 2, the 1, or the -3? This has to do with the order. I gave you guys an order yesterday. So now you've got to know what each one of those numbers does by looking at that chart. And then you have to figure out which one comes first. Yep, I'm going to focus on the +1. What does a +1 do to my picture?
+1 would shift it horizontally.
Can you be more specific?
It would shift to the left one.
Shift to the left one. So that's the first thing.
Yep.
All of these dots are going to go left one. Okay, so that's your picture after step 1. Okay, what number would we focus on next? The 2 or the -3?
2.
2. That's multiplying by a number in front. So now we have to know what that does. Let's go back up. What does multiplying by a number in the front of the function do?
Vertical stretch.
That's a vertical stretch. So when you stretch something vertically, what axis is that?
Y-axis.
That's the y-axis. So a vertical stretch by a factor of 2 means all the y values are going to double. Where would this coordinate end up if you doubled its y value?
-2, 4.
-2, 4. So negative.
Down to about 4.
So remember, the x value is staying the same. The y value is doubling its
Only
height.
the y value doubles.
Yeah.
All right, then it would just go up 4.
So -1, 4. Okay. Where would that coordinate end up if you doubled its y value? Someone, yeah? It would move because it's on the y-axis. It has a y value of 0. If you double it, it's still 0. And where would that y value end up if you doubled it? That would stay the same because it also has a y value of 0. Okay, so that's what your graph looks like, or your picture looks like, after step 2. Took and you stretched it twice as tall. And now step 3 is this. -3 on the end. What does a -3 on the end do? Yeah?
Shifts it down
Down. How many?
3.
1, 2, 3. Do it again. 1, 2, 3. And 1, 2, 3. So that picture in blue, that's the final answer. And that's what they're looking for. All right, so this is testing to see if you can figure out what each one of those things does to a graph. And I usually just draw them all in the same grid. Sometimes they end up kind of on top of each other like that a little bit, but that's okay. All right. So that's 1.6. So again, if you get stuck with domain and range, this I think was a little easier, but the domain and range part takes some practice. Okay, so that's homework for tonight on page 66. So we're going to do, I'm actually going to just change that a little bit, not much. Let's make that 1 and 2. 6, 15, 15. Not worried about 32 either. Okay, so I did change a couple questions, so just make sure you look at that. So 1, 2, 6, 8, 13, 15, 40, and 44, 57, and 63. So 10 questions.
Go back to that list of.
Yep, let me put that chart back up.